Hi, I'm Andrew Wells, a doctoral student at Rice University. I'm going to talk to you today about work conducted with Morteza Lahijanian at CU Boulder and Lydia Kavraki and Moshe Vardi, both at Rice University. So our work will build on previous work in reactive LTLf synthesis and will present probabilistic LTLf synthesis. I'd like to note that code and examples from our work are available on GitHub. We present two approaches to probabilistic LTLf synthesis. The first is by reduction to LTL with existing tools, and the second is by applying specialized LTLf tools. And we experimentally evaluate whether it's worthwhile to develop these specialized tools or whether existing tools are sufficient. So I'd like to highlight two sets of experiments from our paper. In the first set, we fix an MDP and vary the complexity of the formula. Here, the leftmost bar in each graph shows the built-in Prism LTL translation. The middle bar shows Prism calling Spot, and the rightmost bar shows our new approach being called by Prism. And as you can see, when the complexity of the formula increases from top left to bottom right, the runtime gap between our new approach and the previous approaches increases as well. In our second set of experiments, we consider a classical dining philosophers domain with some finite trace property. And here on the left, we see that Prism performs much better than either Spot or our native approach, while for a more complex property, Prism runs out of memory while the other approaches solve the problem. The interesting thing to note here is that Spot and the native approach on the left both produce smaller automata than Prism, yet Prism performs much faster. This suggests we should look for tools that maybe produce larger automata that will work better within Prism. So that was just a sampling of experiments from our paper. You can see more experiments in the paper, and you can find experiments and our code available on GitHub. We presented a framework for LTLf synthesis on MDPs, and we compared an approach using LTL to an approach using specialized LTLf tools. Thank you.